Hello friends, welcome to Best Tutor. This is Rama Vishwanathan. In today's video, we are going to learn one more theorem on circles, that is chord properties of circles. In earlier video, we have learned the chord property of a circle, which is nothing but perpendicular drawn from the center of a circle bisects the chord and the converse. Now today, we are going to learn another chord property. Right. The statement is equal chords are equidistant from the center. Equal chords are equidistant from the center. This is a statement of the theorem. The statement has two parts, hypothesis and the conclusion. Equal chords, this is the hypothesis, are equidistant from the center. This is the conclusion. This is given, this is to prove, this is to be proved. Now let us consider a circle, and a circle is drawn with a center and two chords which are equal. These are two chords A, B, C, D. O is the center. Right, equal chord, that means AB is equal to CD. Now we need to prove that they are equidistant from the center. How do I find out a distance from a point onto a center? If we have to find out the distance between 2 points, it's very easy. We'll take a ruler or a measuring tape, or in any way we are going to find the distance between them. But if at all, we need to find the distance between a point and a line or a line segment. What is the procedure? If at all I have a point and a line segment, I can find out the distance in different way, but I need the shortest distance. What is going to be the shortest distance? The shortest distance from the point onto the line segment is going to be the perpendicular distance. We need to draw a perpendicular from the point onto the line. This is going to be the perpendicular distance, right? Now I need to prove that distance between the center and the chord AB is equal to the distance between the center and chord CD. So let us draw two perpendiculars. So this is the distance OM, is the distance between the center and the chord AB. ON is the distance between the center and the chord CD. So now we need to prove that OM is equal to ON, isn't it? Given AB is equal to CD, we need to prove OM is equal to ON. How are we going to prove it? If at all I prove OM is equal to ON, then the distance between the center and the chord AB is equal to the distance between the center O and the chord CD. That means they are equidistant. We will do a small construction here. We will join OB and OD. Right. Now consider AB is given to be CD. Right, we are going to make use of the previous theorem, that means the theorem which was done in the previous videos. Everything is interrelated. So first of all, let us quickly understand the previous theorem. A perpendicular drawn from the center of a circle onto a chord bisects the chord. So if this is x, this will become x by 2 and x by 2, isn't it? Now AB is equal to CD. AM is equal to MB, because M divides AB. Similarly, N divides CD into two equal parts. AB is equal to CD is given. This implies half of AB is equal to half of CD, isn't it? A is equal to A, so A by 2 is equal to A by 2. Half of AB is equal to half of CD. AM and MB are half of AB, so MB is equal to ND is half of CD. Similarly, NC is half of CD. I will take it as ND. So MB is equal to ND. That means MB is equal to ND. Right. So consider triangle OMB and triangle OND. In these two triangles, what all are equal? Let us understand. OB is equal to OD. What will be the reason? OB is equal to OD. They are the radii of the circle. Radii. Reason is a must. Radii of a circle are equal. Now OB is equal to OD and MB is equal to ND. Just now we have proved above. MB is equal to ND. already proved. And angle OMB is equal to angle OND is equal to 90 degrees, right? That is the construction. Therefore, OMB is congruent to triangle OND. Congruent to triangle OND. What is the axiom we have applied here? Right angle, hypotenuse, side. Right angle, hypotenuse, side. Isn't it? So, it's going to be RHS axiom. Therefore, the corresponding parts of the congruent triangles are equal, implies OM is equal to ON by CPCT. That means OM is equal to ON means chord AB and chord CD are equidistant from the center. That is what is proved. So, what is given? AB is equal to CD. Two chords which are equal is given. We have proved that they are equidistant from the center. What will be the converse of the statement? Chords which are equidistant from the center will be equal. That means OM is equal to ON is given. Prove that AB is equal to CD. If we just follow the reverse order of the same proof, it is applicable over there. We will prove, consider triangle OMB and triangle OND. We will prove that MB is equal to ND. If this is equal to this, then AB is equal to CD. We'll go into the details of the converse now. I hope you have understood this theorem. I quickly repeat, equal chords are equidistant from the center. We have considered a circle, two chords which are equal. We have proved that these two triangles are equal. We drew a perpendicular from the center onto both the chords, and those are to be proved to be equal. Right, AB is equal to CD and the perpendicular drawn from the center of a circle onto a chord bisects the chord. So, MB is equal to ND. That is what we have proved initially. Then, considering triangle OMB and triangle OND, we have proved that they are congruent. Once two triangles are congruent, then the corresponding parts are equal. That means OM is equal to ON. Now, let us consider the proof of the converse. Chords equidistant from the center are equal. Chords that are equidistant from the center are equal. Equidistant from the center are equal. What is given? What is to be proved? Here OM is equal to ON is given. We need to prove that, required to prove AB is equal to CD. Consider triangle OMB and OND. OB is equal to OD radii. OM is equal to ON given. And angle OMB is equal to angle OND is equal to 90 degrees, which is given. Therefore, triangle OMB is congruent to triangle OND. Therefore, MB is equal to ND. CPCT. This implies 2MB is equal to 2ND. What is 2MB? Twice of MB is AB. AB is equal to CD. Right. So, we have used the previous knowledge, that is a perpendicular drawn from the center of a circle bisects the chord, and we have proved the statement as well as the converse. So, this is the theorem and converse. In the coming videos, we are going to learn about more theorems of the circles, chord properties of circles. Thank you.